Hi everyone. Today we're going to talk about graphing linear functions, and what I want to do is start off by reviewing what we already know about linear functions. So what we learned was that a linear function, if you're talking about the equation, well, if you're talking about the graph, it just means it's a straight line. That's what the word linear means. Perfectly straight line, no curves. But when you're talking about an equation, what it means, the way you'd recognize a linear function is that you have no exponents, you have just a single x to the first power, nothing else. So here's three examples of linear functions. We have y equals 3x minus 7, f of x equals negative 1/2 x minus 14, and g of x equals 2x. So what you notice is one of them is y, one of them is f of x, one of them is g of x. That doesn't matter. That's really just the name of the function. What's important is x. And if you look at each one, you see an x by itself. And when I say by itself, it doesn't mean there isn't a number in front of it. You can have a 3x, or a negative 1/2 x, or a 2x. That's fine, but you don't have any exponents on it. You don't have x squared, or x to the third power. You don't have the square root of x. Those are the kind of things that makes our graph nonlinear, makes it curve instead of a straight line. So basically, any equation where you only have an x, or we call it x to the first power, that's what you call a linear function. Now, when it comes to graphing functions in general, before we talk about tricks or shortcuts or anything like that, the most basic way to graph absolutely any function at all, linear or otherwise, is just by plotting points, by basically making an XY table, plotting points and connecting them. Now when you do that, you can choose anything you want for x. That's what we call our independent variable. You plug that number in, you do the math, and it tells you what y equals. That's what we call our dependent variable. So remember, independent means you can choose anything you want. I put any number I want in for x. Dependent means whatever I put in for x, depending on what I put in for x, that gives me the answer for y. So let's go ahead and graph this equation right here. Y equals 3x minus 7. We're going to do it using an xy table. So let me go off to the side here. I'm going to set up an xy table. And remember, what I'm going to do is I'm going to go through and I'm going to pick basically any number I want for x. I'm going to plug it in for x and I'm going to get an answer for y. So let me start with 0. 0 is always a good answer, always a good one to start with. So what I'm doing is I'm basically turning this x into 0. I'm going to do the work. So basically I will have y equals 3 times 0 minus 7. 3 times 0 is 0, and 0 minus 7 is negative 7. So when I plug in 0 for x, I get negative 7 for y. So let's plot that point. Remember, these are points. You can think of it as 0, comma, negative 7. So 0 to the right, stay right in the middle, down 7. 1, 2, 3, 4, 5, 6, 7. It's right there on the bottom. There's my first point. Now let's plug in another value for x, maybe 1. 1's another pretty easy one to do. So I'm putting it in the same place. This time I have 3 times 1 minus 7. And 3 times 1 is 3. Always multiply before subtract. And 3 minus 7 is negative 4. So my second point is 1. That's positive 1, 1 to the right. Negative 4, down 4 would be right here. Now, because we know this is a linear function is a straight line. It only takes 2 points to make a line. I could actually draw the line right now. In fact, let me do it. Let me draw the line right now. If I start from my first point, draw a perfectly straight line going through the second point. Hard to draw a perfectly straight line on my slide, but I'll do the best I can. The line's going to look something like that. Now, just to test to see if we got it right, let me pick another number. Let's pick like 4 for x. Let's see what happens over there. Now, to kind of look ahead, if I count 1, 2, 3, 4, 2, 3, 4, 5, it looks like it may be 5 or 6, somewhere up here. That's the answer I should get. So let's check that work. Let me see if I can squeeze it in the bottom here. I'm going to have 3 times 4 minus 7. 3 times 4 is 12. and 12 minus 7 is 5. So that should be the point 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. Yeah, I was about here. I was close. But you see, it only took 2 points. When you're graphing a line, if you have 2 points, you can just draw the line and you got it. But I did one more point just to test to make sure I was right. And yeah, I got a point right on that line. Let's do another one. So let's graph f of x this time, doesn't matter, but f of x equals negative 1/2 x minus 14. And I'm going to do it using an xy table again. And I'm going to start with 0 again. I like starting with 0, because every time you plug in 0 for x, things work out easily. Now, notice I called it an xy table. I should really fix that. Really what this is x and f of x. But we talked about when we used function notation, f of x is kind of the same as y. So when I plug in 0, I get f of x equals negative 1/2 times 0 minus 14. And you say negative 1/2 times 0 is 0. And 0 minus 14 is negative 14. So all of a sudden we have to use scale. We talked about scale in the last module. My graph only has 7 points on it, so I can't count to negative 14, but I could if I was counting by 2's. So maybe I'll do that. Maybe for this graph, I'll count by 2's. And that would make this bottom point right here 0, negative 14 instead of 0, negative 7. So use scale to make your graph fit what you're looking at. And now here's another thing. When I go to find another point on this graph, I don't want to choose 1 for x, because I have fractions here. If I choose 1 for x, and I multiply it by 1/2, 1/2 times 1 times 1 is 1/2, and I have fractions. But if I choose only even numbers, then I won't have fractions. So I probably want to choose 2, or maybe 4 or 6 or something like that. Let me choose 4, just to show you I can pick anything I want. Let's choose 4 for x. So this time I have f of x equals negative 1/2 times 4 minus 14. Negative 1/2 times 4 would be negative 2. And negative 2 minus 14 is negative 16, which is off my graph. So maybe I need to reset. Let's actually get the eraser here. And sometimes you do. That's why we always do math work in pencil. Sometimes you need to make a change. So let's say I need to, maybe I need to count by like 4's instead of 2's. Let's do that. Let's count by 4's instead of 2's. Then my first point, 0, negative 14, would be 4, 8, 12. It would be about 3.5 squares down. It would be right there. And my second point, which is positive 4, negative 16, well, if I'm counting by 4's, that's going to be about 4 squares down. It's going to be right there. So that's 2 points. And remember, we decided it really only takes 2 points to make a line. Once you have the 2 points, you can draw the line going through them. And we've graphed. All right, but we don't want to have to make an XY table every time we do a graph. We want to have some shortcuts, and we're going to learn 2 throughout this module, one today and one a little bit later. For our first shortcut today, I want to talk about how to use intercepts to draw the graph. So remember, one of the things we said is you only need 2 points to make a line. If I know the x-intercept and I know the y-intercept, I can basically just draw a line right through them. Now, to find each intercept, we remember what we learned about intercepts last module. We said each intercept is where the other thing equals 0. So if I want to find the x-intercept, I just make y equals 0 and solve for x. And if I want to find the y-intercept, I make x equal to 0 and I solve for y. So we're going to find and plot each intercept. And I said, remember, that an intercept happens when the other thing is 0, and then you draw the line through those 2 points. So for our last example today, let's graph this one. And the first thing you notice It's not in y equals form. You can do this trick in y equals form, but this trick works best when it's actually, this is called standard form, when the x's and the y's are together, and then it's just equal to some number. So we have 2x minus 5y, that's grouped together, and it's all equal to 10. So I said, let's find the x-intercept first. Now the x-intercept is when y equals 0. But here's the trick. When y equals 0, it doesn't really matter what number is in front of it. If I have a negative 5y, negative 5 times 0 is still 0. And 0 is nothing, it just disappears. So really what I'm doing, when I'm finding the x-intercept, I'm saying if this whole y term was not there, if that was 0, then the equation would just say 2x equals 10, and I can solve that in one step. I divide both sides by 2, cancel that 2, and x equals 5. So with very little work, the x-intercept is positive 5. So I count 1, 2, 3, 4, 5 spots to the right, and I put a point there. Okay, now let me go back to the original equation. I'm going to erase that first part. Now for the y-intercept, I do the exact opposite. I say, what if x is 0? Well, if x is 0, 2 times x is also 0. So again, we can do the same thing. Basically, if x is 0, that whole thing cancels out. And what's left is negative 5y equals 10. And then you solve that one by dividing by negative 5. Negative 5 cancels with negative 5. Positive 10 divided by negative 5 is negative 2. And that's your y-intercept. So if the y-intercept is negative 2, then you start back at the middle, you count down 2, and you mark a point. So we have our x-intercept, we have our y-intercept. The graph itself is the line that goes through those 2 points. And that's easier than doing an xy table. It's real quick. I sometimes call this the cover-up trick. You cover up the x term and you solve for y. And then you cover up the y term and you solve for x. That gives you your intercepts. You know, cover up means like each one disappears. Like what I did in the notes, I put an x through them one at a time. If you're looking at a problem in a book or you have it written down on your paper, just one at a time, cover up the x part and solve for y. Cover up the y part and solve for x. And then that gives you your intercepts and you draw a line right through it. So that's what we're doing today. We're starting the process of graphing lines. There's another real good shortcut we're going to learn later this module. But for now, we're graphing by either just plotting points. You remember, you can always just make an XY table. And when you're doing that, you put any number you want for x and find the y that goes with it. Or if you want, later in the second part of the homework, you're going to do this trick. You're going to do it by finding the intercepts by one at a time, having either the x be or the y be 0, and solve for the other thing.